In this problem, we are producing a buffer system. Start with a weak base and add the strong acid, hydrochloric acid, into the weak base. So when we add a strong acid, the weak base will be neutralized, will be titrated or reacted to its conjugate acid, Hb+. Then conjugate acid, Hb+, and the weak base will form the buffer system as targeted. And we have the Kb value for weak base. So let's start working on this problem. When we add strong acid, we have B with weak base react with added strong acid. Strong acid will completely dissociate into H+. It gives us Hb+. So initially, because we add into solutions, the volume changes, so it's easier to dealing with the mole number. So initially, with 25 milliliter, so for the base is a 75 milliliter of 0.400 molar of the base. That gives us, you can do the calculation on your own, that gives us 0.0300 mole of weak base. And strong acid, hydrochloric acid, with 25 milliliter and 0.500 molar, this leading to 0.0125 mole. And initially we don't have Hb+. Then because the mole number of H+ is smaller than the weak base, therefore H+ is a limiting reagent in this reaction. Keep in mind, this is reaction. This is reaction, not equilibrium. Change will be minus 0.0125 mole, minus 0.0125 mole, and plus 0.0125 mole. And final mole number, we have 0.0175 mole of weak base, 0 mole of strong acid remaining, and 0.0125 mole of conjugate acid of the weak base. So then this leading to the concentration with total volume as 100 milliliter. This leading to the concentration as 0.175 molar for base, 0.125 molar for its conjugate acid. After this, we will consider the equilibration for this Hb+ as a weak acid, equilibrate with H+ and B. So there's a many ways to deal with this. This is one of the possibilities I'll show here. I go this way because this is consistent with our learning of the buffer system, that we have weak acid with its conjugate base. Of course, there's many other ways to deal with this, but this is just consistent with what we learned in class. So now this is equilibrium, and the equilibration constant for this as a weak acid is Ka, and we're given Kb value here. We're given Kb as 1.90 times 10 to the negative 8. Then we can calculate the Ka value as Ka equal to Kw over Kb, and it is 1.00 times 10 to the negative 14 over 1.90 times 10 to the negative 8. Ka value is 5.26 times 10 to the negative 7. Now we consider the equilibration. Initially we have Hb+ 0.125 molar, B as a weak base 0.175 molar, we have 0 H+, then the equilibration will shift towards right. We increase by X amount for H+, increase X amount for B and decrease X amount for HP plus. At equilibration, we have, equilibration should be like this. Equilibration, we have 0.125 minus X for H plus, 0.175 plus X for B. This is equilibration. Therefore, X times 0.175 plus X over 0.125 minus X equal to Ka equal to 5.26 times 10 to negative 7. Because Ka value 5.26 times 10 to negative 7 is much smaller than the initial concentration of the acid base, 0.125. Also, it is smaller than 0.175. We can assume that X is much smaller than 0.125 as well as 0.175. So therefore, 0.175 plus X is about 0.175. 0.125 minus X is about 0.125. And equation will become X times 0.175 over 0.125 equal to 5.26 times 10 to negative 7. This leading to X equal to 3.76 times 10 to negative 7, which is much smaller than 0.125 and 0.175. And this X is the concentration of H plus. So we have H plus equal to 3.76 times 10 to negative 7, pH equal to negative log H plus. We'll plug in this number, give us pH as 6.425.